We're going to start our lesson today on page 534 in your booklet. So if you could turn there, please. We'll just do a quick review of the unit circle that we learned yesterday. Okay, so yesterday we learned the coordinates for each of the degree or each of the angles around the unit circle. And we actually learned that really we only need to know the first quadrant. As long as we know the coordinates for this first quadrant, we just reflect that across the y-axis, reflect that across the x-axis, and we can get the coordinates for all of the other three quadrants. Okay? Remember that the first term in the ordered pair gives you your cosine, the second term gave you your sine, and then we just had to figure out what tangent was because it isn't part of that ordered pair. Okay, now we're just going to make a note at the top of your page here. Remember that tan is y over x. Okay, so if we were going to figure out the tangent then for this first 30-degree angle, or this pi over 6 angle here, then we would do, this is tan of pi over 6, and it would be 1/2 divided by root 3 over 2, because that's our y over our x. Okay, what that really means is 1/2 times the reciprocal of root 3 over 2, which is 2 over root 3. So when you multiply that, you've got 2 over 2 root 3. Your 2's would cancel out, so you'd be left with 1 over root 3. But as we know, we would never leave a radical sign in the denominator, so we're going to multiply top and bottom by root 3 over root 3, which really is just multiplying by 1. So we're not changing the value of it at all. We're just multiplying by 1. So on the top, we've got root 3 over root 9 on the bottom, and the square root of 9 is 3. So root 3 over 3 is our tangent of the 30-degree angle, the pi over 6 angle. So root 3 over 3. Okay, let's figure out our tangent then for the 45-degree angle, pi over 4. It would be your y over your x, again, so it's root 2 over 2 divided by root 2 over 2, which is just 1. So tangent of 45 is 1. And then we'll figure out the tangent of the 60-degree angle. We'll use our space over here to do that. So again, it's going to be your y. This is tangent of pi over 3. Okay, so it's going to be y over x, which is, your y is root 3 over 2, and your x is 1/2. So what that really means is root 3 over 2 times the reciprocal, which is 2 over 1, which is 2 root 3 over 2, which simplifies. Your 2's will cancel out. You'll have just root 3 left. So the tangent of the 60-degree angle, pi over 3, is just root 3. Okay. Now what we learned last day is this gives us our cosine, our sine, and our tangent for each angle. Cosine, sine, tangent, cosine, sine, tangent. And if we know those, then we just reflect them across the x-axis or the y-axis. So let's do that. Let's reflect across the y to get our quadrant 2. And we know that all suckers take chemistry. And so in quadrant 2, sine is positive, but tangent will be negative. So this will be negative root 3, this tangent. This one will be negative 1, and this one will be negative root 3 over 3. Then again, we're going to reflect over the y-axis, and we know that in this quadrant, tangent is positive. So this means we have a positive root 3 over 3, we have a positive 1, and we have a positive root 3. Okay, then again, we're going to reflect back over the y-axis, and we know in this quadrant that cosine is positive, so our tangents will be negative. So we'll have a negative root 3 over 3, we'll have a negative 1, and we'll have a negative root 3. Okay, now that we have them all, let's just do a really quick observation that there really is only 3 fractions or ratios that you actually have to learn. We've got half, we've got root 2 over 2, and we've got root 3 over 2. Okay, so really those are the only three fractions or ratios that you actually have to learn. Yesterday you asked me if the special triangles would be on your formula sheet. I did look further into that, and no, they will not give us the special triangles. So you really just have to memorize these fractions, these ratios. And there are, like Will pointed out to us yesterday, many patterns happening here. For instance, if you look this way, we have 1, 2, 3, and then it goes the opposite way, 3, 2, 1, and they're all over 2's. Okay, so that's one way that you can remember it. There's lots of different patterns happening here, and it really and truly is just a matter of memorizing. And all you have to do is memorize, like I said, this very first quadrant, and once you have the first quadrant, then you just reflect it and you've got all the other quadrants. Okay, so really spend some time studying this unit circle, particularly these coordinates, these x and y coordinates, because then you'll have your cosine, sine, and tangent for every degree or every angle on this unit circle. Let's go through now and just quickly mark cosine, sine, tangent on each of them, so that you'll just have them at your fingertips when you need them for the questions we're going to do today. Okay, now the other one that I wanted to show you was those questions the other day where tangent was undefined, or where some of the other ratios were undefined. Let's just have a look again. If we know that our tangent is y over x, then let's figure out if this is at 360 degrees or at 2 pi rads. We've got our cosine, we've got our sine. What would our tangent be? Tangent would be y over x, so it'd be 0 over 1, which is just 0. So in this case, our tangent would be 0 at 360 degrees or 2 pi. Same thing at 180 degrees or 1 pi, because your tangent would be 0 over negative 1, which is still just 0. So your tangent would be 0. So we have our cosine, sine, and tangent at 360 degrees or 2 pi, and at 180 degrees or 1 pi. Then let's have a look and see what it is at 90 degrees. Again, it would be y over x. So this time we would have 1 over 0. Oh, this is where tangent is undefined, because you can't have a 0 in the denominator. Okay, so you have your cosine, you have your sine, and you have your tangent undefined at 90 degrees or at pi over 2 rads. Same thing at 270 degrees. You've got your cosine and your sine. Your tangent, again, would be y over x, which is negative 1 over 0. Again, it would be undefined because you can't have a 0 in your denominator. So tangent is undefined at 270 degrees or 3 pi over 2. Okay. Now I just want to show you at the bottom what the policeman is saying. In the unit circle, we know that our radius is 1. And so if our sine is y over r, and our r is actually 1, then really sine is y. Okay? That's why up here on the unit circle, our sine was our y coordinate in each of these ordered pairs. Okay? Sine is y when your radius is 1. Okay? Same thing with cos. If cos is x over r and our r is 1, then cos is equal to x. Okay? So just wanted to show you that so that you would understand where we got the fact that the x coordinate was your cosine, the y coordinate was your sine. Those were not just pulled out of thin air. It's because when your radius is 1, that your sine is actually y over 1, which is y. And your cos is x over 1, which is x. All right, so let's just flip over the page and we'll try a couple questions. I'm just going to save this unit circle just so that I don't lose it and have to rewrite it again. Because technology is wonderful, but once in a while it lets us down. All right, class example number 1. Use the unit circle to find the exact value of all the trig ratios for a rotation angle of 300 degrees. So they've asked us to find sine of 300, cosine of 300, and tangent of 300. And then as well, their inverses, all for 300 degrees. Okay, so really and truly, this is as easy as just looking on your unit circle, and you can read what sine of 300 degrees is. Because we've done all the work now, we filled it all in. Let's find 300 degrees. It's right here, and the sine of 300 degrees is negative root 3 over 2. That's why knowing your unit circle simplifies things, and you can figure out the answer lickety-split. Okay, cosecant, this is just the inverse. And so we know that if sine of 300 degrees is negative root 3 over 2, then cosecant of 300 degrees is just 2 over root 3, and it's still negative, right? It's just the inverse. We just flip it. Okay, cosine of 300. Well, again, look back on your unit circle. And this time, 300 degrees, the cosine is 1/2. Okay, and if cosine of 300 degrees is 1/2, then the cosine of the inverse is just 2 over 1, which is 2. Again, tangent of 300 degrees. Well, if you look on your unit circle, tangent of 300 degrees is negative root 3. So the inverse of that would be 1 over root 3. But we wouldn't leave it like that. We would multiply by root 3 over root 3. So really what we have is negative root 3 over the square root of 9, which is 3. Negative root 3 over 3. Okay. Number 2, use the unit circle to find the exact value of, and this time instead of being in degree measure, we're in radian measure. Okay, like I told you, we'll just be flipping back and forth and flipping back and forth. In fact, this one flips back 2 degrees, doesn't it? Okay, and again, we can just look right on our unit circle to find the cosine of 3 pi over 4. So if you're looking, here's 3 pi over 4. It's the same thing as 135 degrees. And this question's asking us for the cos, that's negative root 2 over 2. Okay, if we want the cotangent of 5 pi over 3, then this is, we could do this a couple different ways. We can do 1 over the tangent of 5 pi over 3. Or we can figure out what cotangent 5 pi over 3 is in our calculator, and then just put it, take the inverse of it, although that's going to give us a decimal, and this is asking us to find exact value, right? So we are going to have to actually do it the way that I've written on the board, 1 over the tangent of 5 pi over 3. Okay, so let's find out what the tangent is of 5 pi over 3. So where is 5 pi over 3? Oh, here it is. It's this one. The tangent of 5 pi over 3 is negative root 3. So we've got 1 over negative root 3. Well, again, we can't leave it like that, so we're going to multiply by root 3 over root 3. And so we'd have negative root 3 over 3. Okay, tangent of 600 degrees. Well, let me just think about that for a minute. That's 360 plus another 240. That's going to be down here in the third quadrant. Okay, so I'm really trying to find the tangent of, I can figure that out if I couldn't figure that out in my head just by subtracting 360, subtract 360, and I'll eventually be left with 240. Okay, so this is the same thing as saying tan 240. And the tangent of 240 degrees, well, I can read that off my unit circle. Tangent, 240 degrees. Here it is. The tangent is root 3. Okay, and the last one is cosecant of 3 pi. Okay, Well, again, let's just figure out where that would be. Mrs. Baker says always, always, always draw it, because that's the easiest way to picture it. Well, if this is 2 pi, and this is 1 more pi, I'm going to end right there. So in other words, what is the cosecant of pi? Is what it's asking. Well, what is the inverse relationship? Well, cosecant is the inverse of sine, right? Okay, so what is sine pi at 180 degrees? Sine pi is 0. So the inverse of that then would be 1 over that, because you take the inverse of it and that is undefined, right? So the cosecant of that angle is undefined because you can't have a 0 in your denominator. Okay, let's jump down to question number 4. Question number 4 is a very interesting question. What it's saying is that I have a point, P, that is at root 2 over 2 and negative root 2 over 2. And I know the coordinates of another point, Q, which is at negative 1/2 and root 3 over 2. And they are both on the unit circle. If an object rotates counterclockwise from point P to point Q, through what angle has it rotated? Answer in degrees and in radians. They want both measures. Okay, so first of all, P is at, let's just look on our unit circle and see where would P be if it's at, the point that lies on it is at root 2 over 2 and negative root 2 over 2. Root 2 over 2 and negative root 2 over 2. Here it is. Okay, so this is actually 315 degrees, 7 pi over 4 rads. Okay, so P is at 315 degrees. Woo. Or 7 pi over 4 rads. Okay, where's Q? Find it on your unit circle. It's going to be at negative 1/2 and root 3 over 2. It's at 120 degrees, or that's 2 pi over 3 rads. Okay, so let's draw where these 2 points would be. Okay, 315 degrees would be in quadrant 4. So we have P here. And we have our Q at 120 degrees, which would be like there. There's point Q. Okay? What this question is saying is, if an object rotates counterclockwise from point P to point Q, through what angle has it rotated? What is that whole rotation angle? Okay, well, first of all, let's see if we can figure it out in degrees. Okay? If point P is at 315, what would this reference angle here be? 45 degrees. Okay, what would this angle be here? 90 degrees. What would this angle be here if this is 120 and this is 90? 120 minus 90? 30 degrees. Okay, so in essence, all I have to do to figure out the measure in degrees is add those 3 angles, 45 degrees plus 90 degrees plus 30 degrees, and that will give me a grand total of 165 degrees. Okay. Now if I had to do it in rads, let's see if we could figure it out in rads. Okay, well, I know that this is 7 pi over 4, where P is. Okay, so if I've divided my unit circle into fourths, and I've gone 7/4, I know that this one would actually be 8 pi over 4, right, which is 2 pi. in lowest terms. And so that tells me that this little section here is just 1 pi over 4 chunk, isn't it? So I've got a pi over 4 chunk. Okay, what about this chunk here? How many pi's over 4 would that be? Right, that's 2 pi's over 4. Okay, and then this little chunk, I have a 30-degree angle. Those are my pi over 6's, right? So that's a pi over 6. Okay, now if I have to add all of those, I need common denominators. And right now, I don't have common denominators. So let's see, what would be the lowest common denominator that they would all divide into? I'm going to have to go with 12s. Okay, so to convert pi over 4 to 12s, I'm multiplying the denominator by 3, so I'm going to multiply the numerator by 3 pi. Same thing with this one, I'm multiplying denominator by 3, so I'm multiplying the numerator by 3, 6 pi. 6 in the denominator, I'm going to multiply by 2, so I multiply my numerator by 2. So I've got 3 plus 6 plus 2, that's 11 pi over 12, which is 165 degrees in degree measure. Okay, example number 5. Without using a graphing calculator, determine the exact value of log in base 2 of cosine 7 pi over 4. Ooh, they're combining a few things there, aren't they? They're combining logs from a previous unit with what we now know about the unit circle and the trig functions. Woo! So they are testing us to see if we know our stuff. So you will find that on the test. They will not just isolate certain topics always. They will sometimes put them together in tandem, and you'll have to show what you know. So first step on this is we're going to figure out what cos of 7 pi over 4 is. Okay, so again, look on your unit circle, find 7 pi over 4. Seven pi over 4 is right here. Okay, so I'm looking for the cos of it. The cos of it is root 2 over 2. Okay. So I've got log in base 2 of root 2 over 2. Okay. Now, instead of keeping this as root 2 over 2, I'm going to rewrite this as, we know that root 2 is the same thing as saying 2 to the half power, and that's over 2 to the 1 first power, isn't it? Okay. Now, when I have the same bases, I know that I subtract the exponents. So this is log in base 2 of 2 to the, what's 1/2 minus 1? Negative 1/2. Okay? Now, I also know when I have an exponent, and it's like the third level like this, the exponent comes down in front. That's the power law of logs, right? So I've got negative 1/2 times log in base 2 of 2. I also know that when my base and my standard value are the same, that's the same thing as 1. So what I really have is negative 1/2 times 1, which is negative 1/2. Okay, tricky stuff, but it's good review for us, good practice for us. All right, this one says, the point A, and it gives us the coordinates of that point, lies on the unit circle. Determine the value of theta, where theta is the angle made by the positive x-axis and the line passing through A. Okay, so I'm going to kind of figure out, first of all, what quadrant this would be in. Okay, because I have an x value and I have a y value, but both of those values are negative. So which quadrant would my x and my y value both be negative? Right, this is going to be in quadrant 3. Okay, so I've got an angle here, and they're trying to find the value of the angle where the angle is the angle made by the positive x-axis and the line that passes through this point A. Okay? So what they're really asking for is this line that passes through A technically would keep going like this, right? And we know from what we've learned about before in geometry that opposite angles would be equal. Okay, those two angles would be equal, so would this angle and this angle. Okay, opposite angles are equal. But if we can figure out this reference angle, then we will know this reference angle as well. Okay? And that's the line that passes through A and the angle that's made from the positive x-axis to that line, right? Okay, so that's what that's asking for. So let's see. If we know x and y coordinates, this is actually our cos and our sine as well. So what we really know about this angle is that the cos of that angle is negative 0.6157. And the sine of that angle is negative 0.7880. So to figure out the reference angle, to figure out this little angle here, we're going to use what we learned yesterday. We can take either one of these two equations. It wouldn't matter because we know the cos and we know the sine. I'm just going to take the sine, but it's the inverse sine of 0.7880. Remember, you use the absolute value, so you wouldn't put the negative sign in there, to figure out what the angle is. And the angle would be 52 degrees if you plug that into your calculator. So what that's telling you is this angle is 52 degrees. This angle would also be 52 degrees because they're opposite angles. And opposite angles are equal. Okay? Now, how could we calculate then if we know that this angle is 52 degrees? How could we actually calculate this whole angle here to there? That would be 180 degrees plus 52, wouldn't it? Which would be 232 degrees. All right, we're actually going to jump over to page 537, and we're going to talk about the equation of the unit circle, okay? So what this is saying is if we have a point, P, on the unit circle, it has an x and a y coordinate, okay? And we can always use the Pythagorean theorem to determine the equation of the unit circle. Well, we know the Pythagorean theorem is x squared plus y squared, and in this case it equals r squared, which in this case, because our unit circle has a radius of 1, we know that our r is 1, so it's 1 squared, right? So the equation of the unit circle in essence is x squared plus y squared equals 1, okay? Because the unit circle has a radius of 1. Okay, so if you have any circle with a center at the origin and you don't know what the radius is just r, okay? As long as it's set at the origin, in other words, it's standard position, then the equation of that circle would be x squared plus y squared equals r squared, Pythagoras' theorem. Okay? So then it's really easy to determine whether the following points would lie on the unit circle. Now remember, the unit circle, the equation of the unit circle is this one, right? Where it equals 1, because we know that the radius is 1 of the unit circle, okay? So they've given us these 2 points. This is our x, this is our y, okay? So all we would do is plug that into the equation of the unit circle. So that would mean 1/2 squared plus 1/2 squared would have to equal 1 if that point lies on the unit circle. Okay, if it does not equal 1, then that point does not lie on the unit circle. Okay, so this is undetermined at this point. We don't know if it does. Okay, well, if you have 1/2 squared, that's 1/4 plus 1/4. That does not equal 1. That equals 1/2. Okay, so no, this point does not lie on the unit circle. Okay, okay, this one. We'd have to have 16 divided by 65 squared, and that would have to, if we added that to negative 63 over 65 squared, that would have to equal 1. Okay, and in fact it does. So if you plug that into your calculator, you would get that 16 over 65 squared plus negative 63 over 65 squared does equal 1. So that tells you that that point does lie on the unit circle. Okay, same with this one. Negative 2/3 squared plus root 5 over 3 squared equals 1. And actually, yes, it does. So this point lies on the unit circle. All right, class example number 8. The point where our x is negative 1/5 and our y we don't know lies on the unit circle in quadrant 3. Determine the value of y. Okay, so we're just going to go back to our formula for the unit circle. So we know that negative 1/5 squared plus y squared would have to equal, if it's on the unit circle, it equals 1, right? Okay, so what that's saying is 1 over 25. If you square negative 1/5, it's going to be positive. So I got 1/25 plus y squared equals 1. Now I'm just going to do some regular algebra to isolate y squared. So I'm going to subtract 1/25 from both sides. But again, I don't have common denominators, so I can't solve it until I do. So 1 is the same thing as 25/25 minus 1/25. So y squared is 24/25. And then I just take the square root of that, so I have y equals, now it would normally be positive or negative, the square root of 24/25. But I know that it isn't going to be both of those because this question told me it has to be in quadrant 3. Okay, so think about this for a minute. If it's in quadrant 3, is my y value going to be positive or negative? It will be negative. So it's only the negative one I'm concerned with right now. Now, this is the same thing as saying negative root 24 over root 25. And square root 25 is a perfect square, so that's negative root 24 over square root of 25, 5. Oh, except I forgot, I actually can take out a perfect square. So I have negative square root of 4 times 6 over 5. And I can take the square root of 4, which is 2. I still have my root 6 under the square root sign. So it's actually, in lowest terms, negative 2 root 6 over 5. Okay, question B says the point P lies on the terminal arm of a rotation angle. Determine the exact values of secant and cotangent. Okay, well actually, now that I know my point, I figured out what y is. That's what I was figuring here. So this is my y, right? Now I have both my x and my y. So point P is actually negative 1/5, and my y would be negative 2 root 6 over 5. Okay, if I know that, then I know my cosine and I know my sine. Okay. So then I should be a piece of cake to figure out what my secant would be. Secant is the inverse of which? Cosine or sine? right, should be 1 over cosine, right? So in that case, secant would be, if cosine is -1/5, then secant is going to be -5 over 1, which is just -5. Okay, so if I need cotangent then, it asked me also to figure out cotangent. That's going to be, cotangent is, well, if tangent is y over x, then cotangent is going to be x over y. So I've got -1/5 over -2√6 over 5. Okay, what that really means is -1/5 times the inverse of this, which is 5 over -2√6. So that's going to give me a -5 on the top and -10√6 on the bottom. Okay, I can divide out a -5 from top and bottom, so I'm going to be left with 1 over 2√6. But again, I cannot leave that like that, so I'm going to multiply by √6 over √6. And so that will leave me with √6 over 2 times square root of 36, which is 6. So that is √6 over 12. Whew. We have to know our algebra to do this stuff, don't we? All right, let's have a look at C. Determine the value of theta to the nearest tenth of a radian if it falls between 0 and 2 pi. Okay, there is our domain, 0 and 2 pi. Okay, well, if cos is -1/5, and the question told me that this is in quadrant, looking back at the question, quadrant 3. Okay, so let's just picture this then. This would be an angle here in quadrant 3. Okay, so we've come all the way around to there. Okay, cosine is negative in this quadrant. Oh, suckers, take, whoop, chemistry. Okay. So if that's the case, how am I going to figure out this little reference angle there? Okay, because the value of this whole big angle, theta, would be the same as the value of its reference angle, right? So the reference angle, if I know cosine is -1/5, then the reference angle is going to be the inverse cosine of 1/5. Remember, you have to use the absolute value, not the negative. And that's going to give you 1.3694 for this little angle right here. Okay, so to figure out what this whole angle is, then it's 180, which is pi, because we're in rads here, right? So pi plus 1.3694, which equals 4.5, and it goes on and on, but it's asked us to list this to the nearest tenth, so we'll leave it at that, radians. Okay, we have one last question to look at on the other side of the page. Class example number 9 says, determine the equation of a circle with center at the origin and a radius of 8 units. Okay, if it has center at the origin, you know it's in standard position. So we're going to use Pythagoras' theorem. X squared plus y squared is going to equal 8 squared. Okay, so really the equation then is x squared plus y squared equals 64. That would be considered the equation of that circle. Now they've given us a point that lies on the circle, but this is a very interesting point because our y is b times the square root of 3. But it's the same thing. We're just going to plug that into our equation, and it has to equal 64. So -4 squared plus b times the square root of 3 squared must equal 64. Okay, well, negative 4 squared is just 16. Plus, now I have to remember with this b times root 3, this is actually a product. So this squared applies to the b and it applies to the root 3. Okay, so first let's square the root 3. Root 3 times root 3 is root 9. Square root of 9 is 3. So that's just 3. And then the b is squared as well. Okay, so 3 times b squared. And that equals 64. Then I'm just going to use regular algebra to isolate my b term. So I'm going to subtract 16 from both sides, and I'll have 48 here. Then I'm going to divide by 3, so I'll have b squared equals 16. And so b is going to be plus or minus 4. And that's why the question said to determine all possible values of b, because there's a plus positive 4 and a negative 4 that could be our b. Okay, we are going to edit this assignment a little bit today. I'd like you to do questions 2 to 4, but in number 4 just do A, C, E, and G, and then also do numbers 5 to 15. Okay, so that you get enough practice working with the unit circle and with the equation for the unit circle, and you're comfortable with that before class tomorrow.